Okay, so good morning. This is the first lecture for this course. You guys have refused to come to class. So anyway, I've decided to do this online. Hopefully it will work. So this is Mat204 and the course outline is here in the hotel. You can just go there and download it. So I'm not going to bother to look at it anyway. Okay, maybe we can do a quick look at it. But anyway, the main thing I can just mention is that we will look at inversion of matrices. Inversion of matrices, basically meaning that we will make use of two ways of doing that, finding the inverses of matrices. So you can actually use cofactor method, or you can use row operations, all right? But I'm going to jump in, at least for today's lecture, is mostly on determinant and properties, and then we'll talk more on vector spaces sometime later, inner transformation, and diagonalization of matrices. That's more or less what I intend to cover in this course, all right? So, straight away to get into the course, and let me see, I go to, yeah, so determinants, okay? So the first one is this, hopefully can be seen. Let me see if I can zoom in. Now, okay, like that. That's the first page, which I'm hopefully able to see it anyway. Why do I hide this? Okay, there. So anyway, yeah, so determinants, And I can just go very briefly because we just talk about determinant of 2 by 2, 3 by 3, and then in general n by n. But 2 by 2 matrix, if it's A, which is, let me just zoom in a bit. It's like this, A equals A11, A12, A21, A22. Then the determinant, which is denoted by that A, or this one, is given by the main diagonal A11 times A22 minus A21 times A12. Example, if this is a matrix, we have 5, 3, 1, minus 1, then the determinant will just be 5 times minus 1, which is minus 5, minus 1 times 3, which is minus 3, so we get minus 8. If the matrix was 1, 5, minus 1, 3, then it will be 1 times 3, which is 3, minus 5 times minus 1, which is minus 5. So you get 3 minus minus 5 is 8. All right. Now, if it was a 3 by 3 case, then this is what you have. If our 3 by 3 matrix is A11, A12, A13, and the second row is A21, A22, A23, and third row is A1, A31, A32, A33. Then the determinant can be found in the three following ways, any of the three ways plus more. So if you are using the first row, you just say A11 times the matrix you get by blocking this row, this column and this row, which is A22, A23, A32, A33, minus A12 times, you delete this row, delete this column, you get A21, A31, which is this, then A23, A33, which is this, plus A13 times the determinant of the matrix you get when you delete this row and this column. So it's A21, A22, A31, A32, which is this. Or if you're using the second row, it's going to be minus A21 times the determinant of matrix you get by deleting this row and this column, which is this matrix, plus A22, you delete this row, this column, you get this minus that. And lastly, like that, okay? Now, in the next page, I generalize anyway, because I think these notes you will have and you can look at them more specifically or more in detail in slow motion if you like. So if it's a 3 by 3 matrix, for example, this one here now, if this is our matrix, compute the determinant of this 3 by 3 matrix. A equals 4, 2, 1, minus 2, 3, 0, 3, 5, 6. So if I'm using the first row, it's just 4 times, you delete this row, delete this column, you get 3, 0, 5, 6, which is this, minus 2 times, you delete this row, delete that column, you get 2, 5, 1, 6, plus 3 times, you delete this row, delete this column, you get that. And you expand, you get 77. Or if I'm using the third row, which is 106, then I talk about 1 times the determinant I get by deleting this row, this column, which is minus 2, 3, 3, 5, minus 0 times, you delete this row, delete this column, you get this, plus 6 times the matrix you get by deleting this column and this row, which is 4 minus 2, 2, 3, which is this, which gives you the same determinant, okay? And so I can say in general, now for an n by n matrix, which is what you're interested in, if our matrix is, allow me to move this, If our matrix is this, A11, A2, let me zoom in a bit for you to see better. So A11, A2, A12, A13, all the way up to A1n, that's the first row. Second row, the nth row. You can see the way the first index, 1, 1, 1 means row, 2, 2, 2 means row 2, n, row n. And then the columns are also this column 1, column 2, column 3, column n. So then the determinant of the matrix A is given by, wait, more like a number of steps. One is choose a row or a column along which to expand the determinant. Number two, you compute the cofactors of each entry along it. Now, don't worry about what cofactor is. And number three, multiply each entry by its corresponding cofactor and add them up. That gives you the determinant, all right? Now, page 3 will give us more details about exactly what I'm talking about. Hopefully, I'm not speaking fast. If I am, you can always slow the video down. Right, so here now you do have, in general, exactly what am I talking about? So, row 1, remember our matrix is what? The n by n matrix we have. So if I'm choosing row 1, then I'll be talking about A11 times C11, this is a cofactor of A11. A12 times C12, the cofactor of this entry corresponds to A12, plus all the way up to A1n times its cofactor. Likewise, if I'm using column 1, now I'm talking about A11 times its cofactor plus A21 times its cofactor plus all the way up to N1 times its cofactor. Now, what's a cofactor? Cofactor basically is determined by two things. One is the sign, and the second is the magnitude. So the sign is basically minus 1 raised to the position of the row plus the position of the column. For instance, A11 is the entry in the first row, first column. So the position sign-wise will be minus 1 raised to power 1 plus 1, which is basically minus 1 squared, times the determinant of the matrix you get by deleting the first row, first column. Allow me to go back to the matrix. So the matrix was, so this is page, or which one now? Hopefully I'm more confused here. Sorry, page 2. So this one. Remember our matrix is this one. Let me just zoom in for you to see it properly. So this is our matrix. So the cofactor of this entry, A11, is going to be the sign, which is minus 1 raised to power 1 plus 1 times the determinant of the matrix you get by deleting this row and this column. And that's what I wrote in the other page. Now, I don't know. Oh, yeah, here it is. Perfect. So this is it. When you delete the first row, first column, yeah, if you delete this row, this column will remain with this matrix, which is A22, A23, all the way up to A2n, and all the way like that. If you're looking at C21, now what is C2? You're talking about 21 is this entry here. The cofactor of this entry is going to be minus 1 raised to power 2 plus 1 times the determinant of the matrix you get by deleting this row and this column, which is exactly what you have here. Minus 1 raised to 2 plus 1 raised to times this determinant, all right? And so in general, let me just talk in general, then now we can look at a specific example. I'm trying to make the lecture short so that videos are not too long. Hopefully, anyway, I mean, you can hear. So in general, the cofactor of any entry, they say this entry is ARC, the entry in A in our matrix in the row R or Rth row and the Cth column, all right? So its cofactor, which we denote by CRC, now this capital C, this small c, will be given by two things. You say the position of the row and column. So it's minus 1 raised to power R plus C times the determinant of the matrix that remains on deleting the row R and the column C. That's basically what we have been doing. All right. So let's look at an example now. Allow me to close this. So this menu business. All right. So page 4 is a concrete example. Right, so this is the example we have. So you are required to compute or determine, hopefully it can be seen. Yeah, compute the determinant of this matrix. Let's just zoom in a little bit more. So the matrix is compute the determinant of this matrix A, which is this matrix. I mean, 1, 3, 0, minus 2, 1, 2, 0, 1, 0, 0, 2, minus 2, minus 1, minus 1, 1, 1, 0. All right. At the end of this lecture, if you're able to compute such a determinant of for n by n, this 4 by 4, then I will be, I mean, somewhere that I'd expected you to have arrived. Okay. So the first thing for you to observe is that it's easier to compute determinant along rows or columns that have more zeros, all right? So for instance, you can see this row has 1 0, this row has 1 0, row 3 has 2 zeros, row 4 has 1 0. So in terms of rows, we will choose row 3. If we are using columns, you can see column 1 has 1 0, column 2 has 1 0, column 3 has 2 zeros, and column 4 has 1 0. So it will make sense for you to use column 3. And anyway, for the sake of the practice, here I chose column 3. For your exercise, you will try row 3, all right? Remember, you ought to compute the cofactors. So like now, if we choose row 3, column 3, sorry, so the determinant of A will be given by 0 times the cofactor of 0 plus 0 times cofactor of 0. So 0 times cofactor of 0 plus 0 times this cofactor of 0 plus minus 2 times cofactor of minus 2 plus 1 times the cofactor of 1. Not minus 1, sorry, okay? And this is what I've written here. Now let's just expand it. So 0 times cofactor of 0, you don't need to find the cofactor of 0 because it's just going to be reduced to 0. Likewise for this one. So the only work to be done is here and here, all right? So the cofactors of minus 2 and the cofactor of 1. So to get cofactor, remember what you need. You need the position. So you can see this minus 2, where is it? It's in 1, 2, 3, row 3, and it's in column 1. Wait a minute. So 1, 2, 3 row wise, and then column is column 1, 2, 3. So it's going to be 3, 3. So it's minus 1 raised to power 3 plus 3 times, of course, don't forget this is minus 2 times its cofactor. Its cofactor is determined by the sign times the determinant of the matrix you get by deleting this row in this column. And here I did some working on the side here. I don't know whether it can be seen. Sorry, it's more or less deleted. But anyway, so I deleted this column 3 and this row where minus 2 is. So what remains is 1, 3, minus 2, 1, 2, 1, and then minus 1, 1, 0. All right? So the cofactor of minus 2 is determined by two things. The sign, position where it is. This minus 2, I repeat, where is it? Is in the third row and third column. So that's why I have minus 1 raised to power 3 plus 3 times, you delete this row, you delete this column. If you delete this row and this column, you get 1, 3, minus 2. And then you get 1, 2, 1. And then you get minus 1, 1, 0, which is what you get there. As far as minus 2 is concerned, its cofactor, we are done. Plus, here we're done, here we're done, here we're done. The last one is 1 times the cofactor of 1. Now, where is this 1? This one is in 1, 2, 3, 4, row 4, and then column wise. So these are the rows: row 1, row 2, row 3, row 4. And then the columns are column 1, column 2, column 3. So that's why I've written here minus 1 raised to 7, which is 4 plus 3, row 4 plus column 3, times, now where is it? You delete the row and the column where it is. Now here I did some working for you. So this is a matrix. You delete the column and the row where the entry you're dealing with is. So 1 is in this row, fourth row, third column. So what remains? You get 1, 3, minus 2. Then you get 1, 2, 1. And then you get 0, 0, minus 1. All right? So far, the determinant we are looking for is more or less simplified. So we just need now to compute the determinant of this now 3 by 3 matrix and the determinant of this 3 by 3 matrix. All right? Now, computation of that is not very complicated. Why? Because now we've here I chose now. Again, remember, I've told you that to get the determinant, observe it's always easier to expand cofactors along rows or columns with most zeros. All right? So now we have simplified from 4 by 4 to 3 by 3, 3 by 3. Now for this one, I can see I have a 0 here in this row 3. So I choose row 3 to expand the determinant of this 3 by 3 matrix. So what do I do? Well, it's just minus 1 times its cofactor. The cofactor of this minus 1 is just, this minus 1 is in 1, 2, 3, 1. So it's 3 plus 1 is minus 1 raised to power 4. I repeat, This entry -1 is in column 1, row 3. So 1 plus 3 or 4, 3 plus 1. So it's -1 is to the power 4. So -1, the cofactor of -1 plus 1 times cofactor of 1 plus 0 times cofactor of 0. As far as this 3 by 3 matrix is concerned, that's what we have. Plus, on the other side, you have 1 times, so I use this third row because it has 2 zeros. So I have 0 times cofactor of 0 plus 0 times cofactor of 0 plus -1 times the cofactor of -1. All right? And so this is what we get. Now let's move on. So -1, here we say the cofactor of this one is just positive, so it's just -1 squared. Then we delete this row, we delete this column. What remains? 3, 2 minus 2, 1, which is this, plus 1. Now where is this 1? This one is in this fourth row, second column. Count 1, 2, 3, row 3. All right. And in column wise, 1, 2. So it's 2 plus 3, which is -1. 3 plus 2. So 1 times the sign times the determinant of the matrix you get by deleting this row and this column, which is 1, 1 minus 2, 1. And then plus, well, the last one is 0. We don't bother. So that one is done. The plus on this side, we just have 0, 0. So forget it. You just have -1. And where is this -1? This is in 1, 2, 3, 1, 2, 3. So it's -1 is to the power 6. Times the determinant of the matrix you get by deleting this row and this column. So it's 1, 1, 3, 2. And then remember the -1 is to the power 7, the one we had previously. And then now you expand. So if you expand this is 3. 3 times 1 is 3. And then 2 times -2 is -4. So 3 minus -4 is 3 plus 4. So this is 7. You multiply by this 1, it becomes -7. Plus, remember the brackets said -2 was outside. Plus, here you expand, you just have 1 minus -2 is 3. So this is 3, and this is negative, so you have -3. So -7 plus -3, -10. -10 times -2 is 20. So as far as concerned, this guy is 20. Then on this other arm, we have 2 minus 3 is -1. This is positive, so -1 times -1 is positive, and then there's a minus, so it becomes -1. So it's 20 minus 1, which is 20 minus 1, which is 19. So the determinant of this matrix A is 19. So try it along row 3. Try using this row or any row. I mean, if you will have a lot more work to do, but that's about it, okay? So as far as that is concerned, I think I've done that example. Now, the last part of the lecture, let's go to page 5, which talks about now some special types of matrices. So basically 3 that I mentioned here, what we call the triangular matrices, diagonal matrices. Now, triangular matrices can be, I mean, I can say what you call upper triangular, lower triangular. And if it's both upper and lower triangular, then it's a diagonal matrix. So a square matrix A is upper triangular if all the entries below the main diagonal are zeros. The main diagonal is A11, A22, A33. This for a 3 by 3 case, of course. Whatever is, you can see this forms, the upper part is a triangle, so it's upper triangular matrix. A lower triangular will be the entries below or above the main diagonal would be zeros. So the lower part is lower triangular. And then diagonal is both upper and lower. So it's basically zeros below and above the main diagonal. The matrix will be called a diagonal matrix. All right. So now if we are to find the determinant for these matrices, see what happens. Well, if I choose this row, I choose row 3 or column 1, it will be A11 times the cofactor of A11 plus 0 times cofactor of 0 plus 0 times cofactor of 0. So it will be A11. I delete this row, I delete this column, I remain with this 2 by 2 matrix. What's the determinant of this 2 by 2 matrix? It's just A22 times A33 minus 0. So the determinant of A is A11 times A22 times A33. Likewise for the lower triangular matrix and the diagonal matrix. What's the determinant of this matrix? You use this row. Any of the rows will give you a determinant. So if I use row 1, it will just be A11 times cofactor of A11 plus 0 times cofactor of 0 plus 0 times cofactor of 0. And then that's it. We'll be done. I mean, then it will be A11 times the determinant of this matrix, which is A22 times A33. So the determinant of D is same as determinant of A, and we are done. All right, so that more or less concludes this. Now, the last part for me to mention is now determinant and ERO. Now, ERO is elementary row operations, okay? So let me go to the book that I'll be using so that I conclude the lecture. You will since this course is mostly hybrid, you guys refuse to come to class. So I will give you some videos, some lectures like this online, and then we can meet up sometime when you agree on the to do, exercises, problems, that kind of thing. So really, I should start from 10, but then 10 I'll ask you guys to read. Then I've started from determinants here. All right. And as far as I'm concerned, this chapter is done. Now, properties of determinant, ERO, let me just go there. Now, EROs are basically elementary row operations. All right. You remember the row operations? The row operations were basically three of them, where you interchange rows or multiply a row by a non-zero scalar or add a multiple of a row to another row. That's what we used to call row operations, okay? So now, I wanted to make this video not very long. What I wanted you to notice is if you pick a simple matrix, all right? Like, I don't know, we want a concrete matrix, a 2 by 2 matrix. What happens when you find the determinant of the original matrix, then interchange rows? When you interchange rows, then the determinant becomes negative. So I want you guys to, in the next video, or I don't know if it's going to be a physical meeting, is what's the effect of each of the row operations. One row operation, you say, is multiply a row by a non-zero scalar or a column. Then I want you to check what happens when you interchange rows. When you interchange, we said it just negates a determinant. And when you add a multiple of a row to another row, what happens? Okay, that's basically the next video, which I would give. But for now, I want to stop there. So thank you very much. Let me stop recording. Let's see how do you do that. Okay, stop sharing and then pause the video.